All right, so the question reads, a piece of dry ice, which is solid carbon dioxide, is placed in a test tube. It is then sealed off. If the mass of the dry ice is 0.4 grams and the sealed test tube has the volume of 22 cubic centimeters, what is the final pressure of the carbon dioxide gas in the test tube if all the carbon dioxide vaporizes and reaches, if all the carbon dioxide vaporizes and reaches the thermal equilibrium with the surrounding at 27 degrees Celsius. So this question is simple and straightforward. Let us see how you solve it. So basically, you first have to collect the data. Like I said, it's very important for you to collect the data whenever you're solving any physics question. So we first collect the data. Okay, so the first thing that we've been given here is the mass of the dry ice. The mass of carbon dioxide is 0.4 grams. So mass has been given to be 0.4 grams and the sealed test tube has the volume of, so the volume of a test tube is 22. So the volume is 22 cubic centimeters, which when converted to liters, this is, so when you convert 22 cubic centimeters to liters, you simply have to divide that by, 1,000. So when you divide that by 1,000, you get 0.022 liters. And then the other thing that we've been given here is, okay, so this is what we've been given, and then they're asking us to find the final pressure. So given these two, the mass and the volume, which method do you think is possible for us, or which method can we use to find the pressure? So what we want to find is the pressure of this the final pressure of the carbon dioxide. That's the one that we want to find. So we've been given the volume, the mass, and the pressure. And we've been asked to find the pressure. So how do we know which formula to use? You can write the formulas that you know, but on this one, the ideal gas law is the one that you're supposed to use. How do I know that? Because from the mass, I know I can find the molar mass. I mean, from the molecular formula, from this formula of carbon dioxide, we can find the molar mass. And after finding the molar mass, we can find the number of moles of carbon dioxide in this test tube. So the number of moles is going to be, the number of moles is found by using mass and then everything divided by the molar mass. I don't know what is happening. Let me just share again. Okay. Just started performing. All right. So saying number of moles is found by mass over molar mass. Okay, so the mass over the molar mass. So the mass has been given to be 0.4, and then the molar mass of carbon dioxide, we know to say carbon dioxide. So we have 2 oxygens there. So we say 2 times 12. And then we also have, 2 times 16 rather. Wait, what is happening? Okay, so 2 times 16, and then carbon has 12. So 12, this will just be 1 times 12. So this will give us 32. And then this one will give us, this one is just 12. So when you add these two, you get 44. So the molar mass will be 44. So we put 44 there. Then when you divide, of course, this 44 should be in grams per mole. And then this one on top is in grams. Then when you find, what is happening? When you find this, when you divide, you're getting your answer to be 0. Um, Let me just divide that. So we have 0.4 divided by 44. So you're getting 0.09 or 0.0091. Yeah, this is the number of moles that you have. So after finding the number of moles, we know to say the formula, the ideal gas law, says this, the what is volume pressure times it's the volume times the pressure is equal to the number of moles times the gas constant, then times the time. Yeah, so to find the pressure, we're going to say pressure is equal to nRT, then everything over the volume. So we can now just put in the values. So the number of moles there that we have is 0.0091, and then we're multiplying everything by the gas constant. So the volume that we've been given is in liters. So we've decided to convert the volume to liters. Hence the gas constant that we're going to use will be 0.0821. Yeah, so this one is just a conversion factor. It converts the units to the given or to the required units. And then the time, rather the temperature that the temperature that we're using has been given, the temperature has been given to be 27 degrees Celsius. So you convert this 27 degrees Celsius into Kelvin. So how do you convert? So degrees to Kelvin, you simply just have to add 273 to what you've been given. So when you add 273 to 27, you're getting a 300 Kelvin as the temperature. So this will be 300 Kelvin. Then we divide everything by 0.0, divide everything by 0.022 liters. Then when you do the division properly there with your calculator, you find that the pressure that you will have will simply just be 10.19 atm. So this is the pressure that you are supposed to find. And then, do we have any questions on this one before we can proceed? Do you have any questions? Okay, so if you don't have questions, I think we can proceed to the next question. So we can proceed to the next question. And then if there are, okay, yeah, just the two of you. I was just checking the, I was just checking the